Hello Internet and fellow network engineers. My name is Maxim. I share network design tips and tricks with you on my channel. This video is dedicated to zero-touch provisioning, and this video is the practice one. We'll play a simulation game, acting as a network engineer for the XYZ Corporation, and solve their 4 different real-life scenarios where ZTP can be beneficial for you and your networks. So let's jump in. Today we'll focus on 4 lifelike scenarios simulation which a network engineer can face in a regular day of work. And we'll see and I'll show you how ZTP can actually accelerate and help you in those scenarios. We'll talk about the complex ZTP scenarios, including scripting, and we'll touch hardware and virtual Juniper products in these simulations. So this is the network, sample network of the XYZ Corporation. It has headquarters down below with a dedicated data center on premises. And then there are a bunch of retail offices up above. The first scenario will be yesterday night, one of the border routers went down. So links went down, the power went down, the network traffic recovered because we have a secondary border router. However, the JTAG case was raised and the RMA device is already delivered on site, and the technician is currently mounting it and replacing the existing unit. Scenario number 2, we are deploying a new retail office, let's say retail office number 101. And the SRX 320 is delivered on site. There is another person on site who all have already connected it to power and connected all the cabling except management interface. So we need to accelerate and deploy, provision this device using ZTP. Simulation number 3 will be a data center leaf. So we are expanding our data center. We would like to deploy a new leaf node. It is already mounted in the rack, powered on, all the uplinks and the server side connections are done. We need to, again, provision the configuration. And the final scenario is the lab related. Our company has a dedicated lab server, which is running EventG environment to do tests. And our lab team reports that they struggle and they waste a lot of time setting up lab topologies for the test. They need acceleration techniques to help them build the topologies and build the configurations faster. So we'll focus on these 4 scenarios. And first we'll start with the scenario number 1. So I'm going to connect to the console. Okay, so I'm logging in as a root. In this case, we'll be able to monitor ZTP, but it is completely unnecessary. ZTP can happen even without you logging in. Again, we would like to monitor what's going on. So currently, we see the device is connected via the console, it's running, and it is in the ZTP mode. So what I'm going to do, I'm going to bring up the interface, which is currently connected to the out-of-band management interface on this MX. It is similar to physically connecting out-of-band management interface on the device. And basically, technician reports that they are connecting out-of-band management network. So, and we'll have a look what's going on after we do that. Okay. We can see that the interface is up now. So we are going to the MX and we'll have a look. What we already can see, we see that it is trying to do DHCP requests and listening on FXP0 interface, which is out-of-band management, which we've just connected to. And next we can see that there is a bound interface, FXP0. It means that this interface was able to get the DHCP address. However, it reports that the client does not have a valid configuration. It means it does not have sufficient options to engage in ZTP. And that's why it just basically restarts the whole process again. So if this is something you see, we need to focus on the DHCP server side and understand why this DHCP server is not providing those options. So let's go to the DHCP server and let's have a look at our status of the process. Currently it's running. It is Kia DHCP server. So this is what I will be showing you in this demo because it's an up-to-date open source solution. If you are interested more in theoretical part and how to set up DHCP server, I recommend you ZTP part 1 on the channel. And down below you can see a log messages for the DHCP server. And this is what I currently see. I see that the address is being provided to the client for the 60 seconds lease time. It's a very aggressive lease time. I will cover a little bit later, so why I would like to do such aggressive timing. And also this line means how this client is currently classified. And it is currently classified with this class. All except VMX provisioned. We'll talk about this later in the simulation number 4, related to the virtual environment. However, currently we just need to know that this class does not trigger any ZTP options going to the client. It means we don't have it currently properly classified. So we go to the DHCP server configuration, and I will scroll down to our client class. And this one will be our first client class. And again, the whole point of client class is that when the DHCP client is providing the information to DHCP server in the discover message, it introduces itself by sending several different options. And then DHCP server looks inside these options and classifies it in one or more classes inside, and then it triggers certain actions or certain options being sent to the client. So we have a dedicated class for our border router. And there is a test string right after that. We can see this is currently commented out, but this is active test string. And what it does, it splits the option 60, which is VCI, vendor class information, and it splits it using hyphen as a delimiter, and it is looking at the fourth portion of it. And it is basically a serial number. And it is currently comparing to P1111. And my idea is that just imagine that this is previous serial number of the previous border router, which failed overnight. So what we need to do, we need to change it. We comment out this line, we uncomment this line, which it has the proper serial number of the RMA router. And I save it. And I restart my DHCP process and verify that it is active and running. So I return back to MX and we'll see what's going on. Again, this just, if it doesn't have enough options, it just restarts and can wait until the DHCP server will take action. So we can already see that something happening. There are information being provided to the router. And this is the special string. It says all options set. It means now it has enough options, enough ZTP information to proceed with the ZTP process. And I return back and I check my log, and we can currently see, so we don't see it yet. Oh, no, we do see. So it provides the address, right? Same thing for the aggressive time, but now we can see that it is classified as a previously in that class. However, it is also classified as MX10. It's a specific serial. So this is something I call a prefix device because it is a unique device. We classify it uniquely by the serial number, and then we provide the final information, including the final configuration to it. So let's jump back. Device provides the summary information, the repo address, code, name, the configuration, and then basically the method. It is fetching configuration file, and then configuration file fetched, and then currently it's fetching the image. So while it is fetching the image, so what I'm going to do, I'm going to jump back to the presentation, and we'll look at the next slide. So this is a summary of the scenario number 1. We can see that this simulation involves MX10 router, which is currently connected to 45 port on the out-of-band management switch, and on that side it's FXP0. This device is currently running 21.2 R3S7, and our target version, which we would like to have, is 21.2 R3S8. Again, you never know what code RMA device will be running, so we would like it to be in line with our remaining border router. On the right side, we can see the structure of my out-of-band management network, which is 10.160/24. And if you look from the left side, that one is a gateway, which is basically the firewall, which protects my out-of-band management network. Then .102 is a Kia DHCP server. .103 is HTTP file repository, so we'll look into this a little later. And then there is a range of addresses called pool, which I call waiting room, and this is from .170 to .179 with a very short list time. The idea is that to treat it as a waiting room. So I would like all my devices waiting to be provisioned, to land in this area and then leave it after it is provisioned. For this specific router, I would like everything to land in waiting room, then proceed with the ZTP actions, and when final configuration is committed, I would like it to be changed to the .202 static address. And if you look at the process, router is sending, number one, router is sending DHCP request to the DHCP server, and it is sending VCI, which is Juniper, Extend T, and then serial number. And this is what I was talking about, the dash as a delimiter, 1, 2, 3, 4, the serial number. So this is how we classify it on the DHCP server side. And then after classification, server is able to assign the address, plus it will send options 150 and 43, which is vendor-specific information, back to the router. Router is then downloading image and configuration. Next step, it does the code upgrade. And finally, after code upgrade and reboot, it is doing step 5, commit of the final configuration. So we are returning back to the CLI, and we can see that it downloaded the file, image fetched, and then it proceeds to the upgrade, and it says to us that system will reboot automatically, and currently it is installing image, and then it will be rebooting. So we'll return back to MX and to our scenario 1 later. So we are going to talk with you about scenario 2 now. Scenario 2, again, our new retail office, SRX 320, connected, powered on, engineer is waiting on site. Theoretically, if you use ZTP, you don't even need engineer on site. You don't need to send your technician on site. You just can basically ship it on site, and then any employee on site can basically take it out of the box and, let's say, connect it and power it on, if you don't have like complex physical mounting or something like that, because you don't need local console, you don't need anything theoretically if you use ZTP. It can significantly simplify your operations. This specific device is connected locally using port G000 to the out-of-band management switch, let's say on site, just imagine, using port 43 on the management switch. This is the lab setup. It is currently running 23.4 R2S2, and the same version is expected to be production. So we are still advertising it from the DHCP server, but in our case, upgrade will be skipped. This specific hardware model doesn't have dedicated out-of-band management interface, and what it does, it is using port 0 copper and port 7 fiber as the ZTP interfaces. So they will be trying to do ZTP on both of these. Our design solution is to use port 0 as a dedicated management port in the dedicated routing instance and the dedicated functional zone. So we will be using it as a management, and currently our next step will be connecting it to the out-of-band management switch, basically bringing up this interface up on the out-of-band management switch. Out-of-band management is very similar, so SRX will land in the waiting room, and after it is finally provisioned, we'll assign it that 200 static address. There will be a little difference between this one and the previous scenario in terms of number one, SRX will be sending DHCP requests to the DHCP server. But in this case, as you probably remember if you watched video number 1 for ZTP, SRX does not send its serial number to the DHCP server. It is sending Juniper and then dash SRX 320 and the specific model, and that's it. It doesn't send serial number. What it means for us, it means the DHCP server will not be able to uniquely identify this device. Just imagine this is retail office 101, but you have also other 100 offices with a configuration slightly different, IP addresses different, passwords probably different, browsing different, etc. IPsec credentials. So we would like to uniquely identify that configuration because it finally needs a unique configuration. So what we are doing right here, the DHCP server will be classifying it as a group, as all SRXs 320, and it sends the response to it back, which consists of image file and the shell script. So the device is then downloading, there is a typo here, it's downloading image and shell script from the file repo. Next step, it is attempting to do code upgrade, which will be ultimately skipped because it is already running the correct version. And next, it will execute shell script. And in shell script, what it will do, it will extract local serial number. And then it will construct the file name for the final configuration using its serial number in the middle, like as you can see here. And then it will reach out to the file repo and download that unique configuration file for that specific device. And it will commit it. So let's go and have a look. Currently, I log into the console server again for the monitoring. We don't need to do any configuration or any commands on the SRX. We will be monitoring. So I'm going to unshut out-of-band management connection. Okay, it's very similar to someone plugging cable locally from the out-of-band management switch to G000 on the SRX. On the SRX itself, we can see that the device is attempting ZTP, and this is what I was talking about, what interfaces it is doing that. Okay, so we can already see some options coming, all options set, which is a good sign. We'll verify the log, and we can see it is getting 170. And remember, 170 used to be for our MX to EFF. Now 4AE4 is taking the same address. This is the whole purpose of the waiting room. We don't want those addresses to be used for long. So that address was released and this device is taking it. And we can see that it is also classified by the group SRX320 firewalls, like a general group. So this is what we see. And let's connect to our, so while we are waiting, we'll connect to the file repo. This is the structure inside my file repo. So let's look into configs and images. So I have images, let's say a couple images for MX, couple images for EX, and couple images for SRX, which I can utilize. And in my config folder, I can look, this is my SRX shell script, which it is being downloads and instructs to download during ZTP. And this is the final configuration for SRX. So let's have a look at it. Okay, yeah, so it is still preparing. The device is still preparing. So we are going to have a look at the shell script. When you provide the configuration file to the device, the first string will decide if it is a configuration file or a script. It can be different types of scripts, including Python. For this specific scenario, I'm using shell script, and this is the indicator that this is shell script. I'm using some echo commands to save certain outputs to the log file, which we'll be able to monitor later after device is provisioned to make sure that everything is correct. And as I mentioned, step one, I create a variable, which is, again, extracting serial number by doing CLI command, show chassis hardware, grab chassis. And then I'm extracting second portion of that line. It looks like chassis, serial number, and then model. So I'm looking at the portion number 2. Then I output my variable, which is received. And then I basically construct the configuration file, which I will use to download. And then next step, I'm doing a chain of CLI commands. I'm going to the configuration mode. I do load override, and with the configuration file I download from the repo. And then I do commit and quit. So this is what the script is doing. This is what we can see during ZTP on SRX. We can see that shell script is instructed to do, right? Because again, DHCP server doesn't know that if this SRX is from Retail Office 101 or 51. The SRX itself on its side will execute the script, find out its own serial number, and then go and fetch the configuration from the file server. And this is very efficient because you just need a single class on your DHCP server, and it can handle hundreds of SRXs of the same role or the same type. Which is very efficient. Currently, it is downloading script downloaded. Currently, it's downloading image. It still needs to download image to compare to the currently running version. So what I'm going to show you next, I'm going to show you the final configuration for SRX. And this is what I will be doing. Yeah, the whole idea is I would like to, and this will be final configuration for that specific device with that specific serial number. So I'm doing root password, I'm doing some web credentials, I'm enabling SSH, DNS, NTP, I'm doing the out-of-band management interface with the static address, as I mentioned before, functional zone, and dedicated routing instance for management. So again, this is just a sample example of configuration. So obviously you can enhance it and make it basically final for that device and generate it from the template before the provisioning. Yeah, so while it is downloading, I'm going to show you the DHCP server configuration, specifically class for our SRX. Yeah, so this is down below. This is how I classify it. I'm basically taking option 60 VCI coming, and I'm just comparing it all together with the Juniper SRX 320 fixed line. If it is true, it is classified in this class, and these options will be sent out to the client. This line means that we need to send VSA option 43. Without this line, it would not send it. And then all these information is being encoded with the different codes inside the option 43. And then we also utilize option 150, which is standard option to provide the file repo ID. Yeah. So we can see that image fetched, and then we can see a message that image installation is aborted because installed and fetched images are the same. Good, and currently it is executing script. So we'll have a look of our result in a moment. So meanwhile, what I will, in order to not lose time, we'll talk about a few things about DHCP server. We can see option definition. So we defining our options first, and this is something which is well covered in ZTP part 1. Then I have my subnet defined. So currently I use just single subnet, but I use two different pools inside. So currently this is the pool which is waiting room, and we'll touch this pool later in the virtual environment and why I need it. I provide the default gateway. I don't provide DNS because every DNS is already configured in the final configurations when devices are provisioned. And then there are different classes, so which we'll cover going forward. SRX, so we can see a message, script executed successfully, and there is a hint, check log output to see the details. So what I usually recommend if configuration is significantly changed and you logged in before that, it is better to log out and then log in. So just imagine that we are logging in after the fact, after everything is provisioned. So let's have a look. So step 1, I'm doing configuration. And we can see that this device is provisioned by ZTP, and we can see our static address. So because this is a unique configuration file. Okay, so I'm doing show log, and the log file is called script output. And this is where I see all my echo messages. So I currently see this is the device serial number, which was extracted from the command. And then this is the configuration file name I'm constructing from the static portions and the dynamic serial number. Then we can see it's entering configuration mode, downloading the config file, and committing the final configuration. So very simple, very short script, and overall very efficient in this case. And again, it's script, you can do basically a lot of different things. You're very flexible, whatever you need to do. So SRX is finally provisioned with a unique configuration. So this scenario 2 is completed, and we are going to proceed to scenario 3. Scenario 3, we are deploying new data center leaf node. We imagine that this device was previously used somewhere in our network, and then it was no longer needed. It was decommissioned and zeroized and placed in the box. Now we need it again. We deliver it from the warehouse. Again, EX, QFX, so this is just something I have in my lab. This device is already installed in the rack. Okay, servers are connected, uplinks are connected, just the management interface is not connected, similar to a thing before. It is running 24 to R1S2, and the target version is the same, because again, it was used before and recently decommissioned, so we will skipping upgrades in order to save time. Same idea, the device will be landing in the waiting room, going through the ZTP provisioning, and then landing with a .201 static address. So in this case, it will be easy to, let's say, SNMP pollers, monitoring stations to connect to a static address later, and it will not waste space in the waiting room. So number one, the device will be going out to the DHCP server, and it is providing this VCI, Juniper EX2300-48T and serial number. And then theoretically, it's great, right? I can classify it uniquely already because I see the serial number. However, there is a catch. So the idea was let's imagine that there is a requirement from management. If we utilize ZTP, we would like it to be zero touch and device should be completely provisioned after it. But in our case, in this data center, there is a requirement to have a certain Python operations on-box script engaged and ready on each device when it enters production. And this script, which I created, is called jtag-files.py. And this script helps you to collect RSI and var logs and save them to var tmp folder. Those are two files necessary if you open a JTAG case, and you anyway need to collect them. So this op script makes your life easier by doing it for you. And another thing is that when you work with the op scripts on box, the configuration contains of two pieces. First is the pure configuration commands, which is easy to introduce in the configuration file. But second piece is the script itself should be uploaded to a certain folder on the device. And if you would like to do it zero touch, a regular ZTP with the configuration file like we just did on MX would not work because it would not download the script, right? So that's why in this case, the decision was taken that DHCP server will be classifying these DC leaf nodes as just EX2300, similar to SRX use case. And then it will be providing, in response, it will be providing the image and the shell script. So it is doing that. And then the device is going to the repo and downloading the image and shell script. And then it attempts a code upgrade, but code upgrade is skipped. And then it executes the script. So when the script is executed, first part is identical to SRX. It extracts local serial number, constructs final configuration file, downloads it, commits it. Right, easy. So next step 7, it is said hostname fix is committed. Just ignore it. So basically, I just forgot to remove it. There is no need to fix the hostname. Hostname will be taken from the configuration file correctly. And the step 8, it will go and fetch the Python 3 op script from the repo and save it to the proper folder. So basically, it's killing two birds with one stone. We are simplifying DHCP configuration. Again, just single class is required. Plus, we are completely provisioning our DC switch, including file transfers and script setting up. Let's go ahead and have a look. So I'm going to, again, logging into the console server. Oops. Logging in for the monitoring, and I'm going to enable the my out-of-band management interface. Okay, so while it is doing that, I'm going to jump to MX. So MX is still rebooting after the final configuration, after code upgrade. So we'll return to it in a few moments. Yeah. Okay. Let's have a look. We can see that now out-of-band management is up. So we are connected. We already see all options set. So we are able to properly send it. So the idea is that we are checking our DHCP log. We see that this address 171 is being allocated. And we can see that the device is currently classified in 2 classes, including group class for 2300 switches. So that's where the options are taken and advertised to the device from. Okay, so next step, we are looking at the shell script. Yep, let's have a look. Again, special string to indicate that this is a shell script. Just a side note, it can be done in different languages, including Python. Python is more flexible. It is better to handle exceptions. It is better like for a few different reasons. But in certain scenarios, I usually treat them as just two different tools in your toolbox. It doesn't necessarily mean that one is better than another. It's just for different use cases, one is more appropriate, more suitable. So, and this is basically what we are doing. Let's look back on the EX. So this is indication of what is being sent, including that script which we are currently looking at. Downloading a script is downloading image at the moment. So let's jump back. Let's look at the script. Step 1 is identical. We are doing serial number. We are also doing show command, plus extracting second portion of it, displaying serial number, constructing file configuration name, and then we are doing set of CLI commands: configure, load, override, fetch the final configuration file from server, commit and quit. And next we are downloading JTAG op script. So initially what I'm doing, my goal is to verify if this file is already present or not. So this is expected output. So if you do something like file list and then this file script, you can basically have two responses. You can have a response like that. You would expect this response if the file is present, but also if file is not present, you will see a different output. And then I'm comparing them one to another. And if they are the same, I'm skipping and I don't need to copy and replace because it's already done. However, in the other use case, if they're not the same, I'm doing file copy and I'm copying JTAG files.py to the var.db scripts op folder using routing instance management Junos. Remember, we have already committed final configuration. It has a management instance string. And then I'm changing file permissions in order to make it properly executable. Okay, let's jump back. So we can see if the image is downloaded, it is currently verifying if it needs upgrade or not. It indicates that upgrade is not needed, and currently it's executing script. Okay, so in what should be happening after script execution, we will see in our final configuration file. So same idea, this is very important piece. As I mentioned, part 1 of op scripting, we need to specify it properly in the configuration, and then we need to manage, if it is Python, we need to mention it here. I specifically created this op script in Python just again to give you some ideas why Python can be beneficial in certain scenarios, and I will show you in a moment. Some login credentials, SSH, name server, management instance, static address for VME, which is very important. Again, we don't want to use a waiting room spacing, dedicated routing instance, LLDP. So just imagine that this is final configuration for that specific switch. This is what we'll see in a moment right here after script is executed. Yeah, let's look at the scripts folder. So I have, this is the folder where I have my script. Okay, so let's have a look at it. Yeah, we have already specified that this is a Python. We connect to the device, which is, again, if we don't specify anything, this is the device which we are currently running it on. Step 1, I would like to clean any RSI file which may already be created before in the temp folder. And I'm doing an RPC request to file delete, and then I specify the path. So you will see in the internet, you will see examples with the CL lines of RPC. Juniper doesn't recommend it. It is better and recommended way to use RPC calls to do the changes in your Python script. And the idea is that we use try except construction. It basically gives the idea that if RPC will be unsuccessful, like in this specific case, it can be unsuccessful because if file is not present, it will give you RPC error. What I would like to do, if it happens, I would like to print the error and keep going without stopping. So if it is not successful, I'm fine. So next step, I'm cleaning var logs file, which may be present. A similar idea. Next, I'm collecting RSI file using RPC get support information with a custom RPC timeout. It is very important because default timeout is 30 seconds and it is not enough to collect RSI and you would get an error. And then finally collecting var logs. So what var logs is, this is a single archive which collects all the log files from var log folder. It has an RPC file archive, okay, it does compression, and this is the destination where we save it, and this is the source of all files from the var log folder and the custom RPC timeout. And this is basically it, and finally we gracefully close the connection to the device. So this is how op script look like. So let's return back to EX. we can see script executed successfully. So I'm exiting again because I logged in before it was finally provisioned. So I'm going to log in. Okay, so what I'm going to do first, I'm going to check my log, script output. And we can see again serial number extracted, the file name of the final configuration, downloaded, commit complete. This is expected command output, as I mentioned before. Like if your file is present, this is what we see. And this is actual output, and you can see no such file or directory. As you can see, these two are not equals. So it means we are downloading the script file, and basically that's it, and store it properly. So we can check it file list, var db scripts up, and we can see JTAG files here. So it is already present. So next step, I'm doing show configuration to make sure that the configuration was properly applied by the script. And we can see, so this is the custom configuration with the static address. Again, this final configuration for that specific serial number. We have those sections for the script. And dedicated management instance. So and now I would like to test my op script. So let's give it a moment. While it is doing the op script, let's jump to MX. And this is our scenario 1 border router. You can see it already asks us for credentials. Okay, so let's do show chassis FPC peak status. So let's check that it is fully initialized. Let's do show configuration. We can see that it is currently running S8, which is the final configuration. Final code version. It used to be running S7, so it upgraded the code. We can see custom configuration with the static address for the out-of-band management. We can do show version. That's 8. So perfect. Scenario 1 completed. We have the upgraded image, and we have final configuration committed. EX. So what we can see here from the output, we can see that step 1, RPC error occurred, and the error is basically no such file or directory. As I mentioned, it is exception handled. And then var logs file, no such or directory, so they are not present currently. It's okay. Currently, it is collecting RSI file. Be patient, so it can take a minute. So we covered all the configurations, all the scripts here. That's good. And we have looked. We have not looked at the DHCP server side configuration. So let's look into that specific class. And this is it. So what I'm doing here, I'm doing test as a substring. So I take just a portion of option 60, and I'm looking for first 14 characters starting with character 0. And if it starts, as I mentioned, with this string, we classify it in this class. It doesn't matter if it's 48T, 48P, any serial number. We classify all of them at once, and then we send the script, and the devices will provision themselves using the script and download final configuration. So again, efficient way. Let's have a look. We can see success for RSI var logs. Let's verify. So 2 files present. Let's have a look at our file. Okay, so we have RSI. It is about 9,000 lines. So again, you need to open a case. You just run op script. Theoretically, you can modify your op script to transfer those files to your corporate file server. You can do basically a lot of things to even bring it further. But this is the way how you can again make life easier. So DC switch is provisioned 0 touch, including the final configuration, code potentially, and op scripting. Right. So great scenario. Let's jump to the final scenario number 4. And again, as I mentioned before, lab team reported that they have issues because they need to, when they deploy a new lab scenario, lab topology, they have a lot of repetitive tasks which they're wasting time on, like creating management addresses, enabling SSH, user accounts, LLDP, things like that, just regular general stuff. So currently, again, VMX is, in this scenario, we'll be running 22R3S8. We will not be providing any instructions to code upgrade VMX. We're just interested in the configuration. And this portion will be a little different. You remember the waiting room, but my idea that my VMXs will be landing in the waiting room, but I don't want them to be there. And I don't want to use static addresses. Because again, this is agile environments, labs, lab topologies are being deployed and removed. I don't want to do static. But what I would like to do when it is initially landing, it is landing in waiting room. And after final provisioning, I would like it to jump to a different range of addresses inside the same subnet, which is I call VMX lab pool, addresses from .70 to .79. Let's look at the process. And another thing important is that VMX, to efficiently use it for your testing, you need a license. And there is something called evaluation license, which you can get and download from the Juniper website, and which gives you 30 days access for the device. And the thing is that it used to be easy to apply it just by using set command or a licensed terminal. However, not anymore since 19.4, when VMX switched to an agile licensing scheme. So but I found a knowledge base article which makes it possible, but it requires additional steps of saving certain license file to a dedicated folder on the device and then rebooting the device. So again, what it means for us, we have additional steps which needs to be performed, including file transfer. So we cannot just send the configuration file in the ZTP, we'll need also to send a script. So step one, again, VMX is sending a request to the DHCP server, providing its serial number, but the serial number is basically random for different VMXs when they initiate. Even if you zeroize a VMX, it will change its serial number. Kia DHCP server initially classified as something called, in my case, VMX fresh, and sends the options back. So the device will go and download the shell script. Just ignore the config, there is a typo here. So it downloads the shell script, it executes the shell script, and in this shell script, what it is doing, first it is going and downloading general configuration for all VMXs. And this is whole idea. So I would like to, basically all of them after the deployment have a very similar configuration, general configuration, without unique features for between different routers. And then as a next step, it is going and downloading the license file from the file repo, save it to the proper folder, and step 7, reboot the VMX to take effect. So this is what we'll be doing in scenario 4. Yeah, let's go. Okay. This is my lab, EVNG lab environment. Okay. So I'm going to deploy 3 VCPs, which are virtual control plane. So it is a 2 VM. Basically virtual device. So I'm going to initiate a few connections, like test connections. Just imagine that we are doing like a simple topology of 3 routers. This will have G001. This will have G002. Okay, so next step, I'm connecting internal interface between control plane and PFE. Okay, in this case, they will be able to communicate. And the step now, final step, what I'm doing, I'm connecting my VCPs using out-of-band management interface back to my out-of-band management network. Okay, perfect. So you may notice that I'm wiping my VCPs. So sometimes it happens when you deploy them in a bunch, multiple nodes at a time. Some nodes may not be booting, so we need to do the wiping before starting. It's just a proactive measure. Okay, so everything is booting up. So I'm going to open one of the VMXs. So we'll be monitoring it. And meanwhile, I'm going to show you the script from the file repo. Okay, so this is my script. Step one, I'm just doing a chain of CLI commands, configure, and then I download this general configuration for VMX and commit. So this is the easy step. And then next one is download and apply license. The structure is very similar to the EX example. I would like to compare and understand, do we need to do that or not? So if license file is already present on the box, I don't want to copy it and do reboot. So this is the thing, I'm basically collecting expected output to the real output, and then I'm either skipping or proceeding with the download of the license. So I'm doing CLI command file copy to place the license in the config license folder using the dedicated management routing instance, and then I'm doing reboot. So in 1 minute is not important, I would like to do it show you a log output before device goes to reboot. Now I'll show you the final configuration, which will be applied. So yeah, I have some user accounts, SSH, NTP, LLDP, a dedicated routing management instance, but again, you can do whatever you want right here. This is important piece. Remember I told you that management interface, I would like to keep it BDHCP for dynamic reasons, but this is important string. So the string used to be Juniper VMX and serial number, right? And this is how we classify it in the fresh group, fresh class. But as soon as device is provisioned with the final configuration, it will initiate DHCP again on over management interface, and now it will be introducing itself with this string. And it will help me to provision it differently on the DHCP server. And this is what I'm going to show you now. Yeah, let's have a look. Yeah, so this is what I'm talking about. This is the first class, and it is called group Juniper VMX Lab Fresh. And I'm looking at using delimiter colon of second portion, I'm looking that it is VMX. So when VMX is basically just booted. So it is fresh, and this is what I'm sending to it, including the script, right? However, as soon as it finally commits the configuration, again, as I mentioned, it changes VCI when it sends to the DHCP server, and now it's Juniper Lab ready. And as soon as it happens, DHCP server will reclassify it and classify it to the provisioned class now. And after it will do it, it will use a different pool of addresses for it. So, and let's have a look. Let's have a look. Yeah, it's down below. Let's log in, so in order to monitor. Yeah, so this is my subnet. And as I remember, as I talked, this is the dedicated address space for VMXs. And you can see I dedicated to only single class, which is group Juniper provisioned, VMX provisioned. So as soon as the device becomes provisioned, it is jumping to this address space. However, the waiting room, in order to not allow the provisioned VMX stay in this address space because it may have active lease in this space, I'm forcing it to be used only for the class all except VMX provisioned. And if I go down, what this class means, it means that any device which is not a member of provisioned class. So basically all the other devices. So the first pool is only for provisioned, the next pool is for everybody, for every class except provisioned. And this is basically what it is doing to force it to go around and choose a different address space. So let me show you the lab output, log output. Okay, so this is what we currently see. Just let's look at this address. So let's see 172 for 60 seconds. So this is waiting room address, and it is currently provisioned to the device which is fresh, VMX fresh. Okay, and you can see script executed successfully. So let's do show log script output. We can see that it basically downloaded the configuration and committed the configuration because it is just, in SSH is enabled, it generates keys, commit is successful, and then it downloads and deploy license. So obviously the license file is currently not present, it is going to download it and place it, and now it's going to reboot. But now we can see a difference in the log file. Remember, those devices used to have address in the waiting room. Let's focus on this specifically on :4. This is :4. And you can see it jumped, and now it is using that 70 address for the 1 hour lease time, right? So it jumped there because it is now classified as provisioned. So this is exactly what I wanted. Still DHCP, but we are jumping to a different pool of addresses. Okay, so we just one thing left. We are going to wait for the to boot. VMX is doing it very, very efficiently and fast. So it will verify our results. So meanwhile, if you would not do that, right, it means if you deploy 3 routers in EVE-NG, you will need to go and do it manually on each of them. You will need to upload license, you will need to reboot, set your IP addresses, let's say set your management instance, your LLDP, a lot of commands, autonomous system number, a lot of things which you can avoid and not do. So you can basically save you some time, which is great. By you utilizing scripting and Juniper ZTP. Okay, so let's have a look. Show configuration. So, yep, we can see it is enabled by ZTP. So, yep, we are using final configuration. This is good. Show system license. We just need to wait. It is still initializing. Let's give it a moment. It's currently working to initialize PFE. FPC, okay, online. Yep, good. Show system license. Yep, we can see that license is present. Show configure, show LLDP neighbors. Yep, we already see one of our member routers with the same host name. It means they are all also provisioned. Now we see 2. So we can basically say that all the 3 routers are provisioned, and basically lab team can jump in and do the remaining custom configuration and do the test, which saves a lot of time. So, yeah, thanks for watching. I hope you enjoyed the content, and if it is useful, I hope you will deploy something like that in your network. If you're interested in the files, scripts, DHCP server configuration, I will be uploading them to the Juniper Elevate community post, which I will put in the link down in the description. Click a like button, subscribe, it will help my channel and grow the audience. I'll see you in the next video.